Hello friends, today we will discuss what is Docker. So before starting into the Docker, I will suggest to go to the video which I uploaded before, how IT companies work. Because Docker is a part of Devops tool. It is a part of orchestration tool. So before knowing that where the actually Docker comes into pic and why Docker is used, what is Docker, so before this, I will suggest you should know that why DevOps came into the market. What is the opportunities of DevOps? Why all IT companies are adopting DevOps? So in that video, you will get a clear idea that what is DevOps and why DevOps came into the picture. So I will suggest after, if you are a fresher or if you are a beginner to the DevOps, then I will suggest you to watch through that video. Or if you have the clear concept of DevOps, then you can start with this Docker video. So in this video, I will say what is Docker and why Docker is booming in the market nowadays. So Docker is a containerization tool, or we can say Docker is a virtualization tool. So before Docker also there was some virtualization tool which I discussed in my previous video. What is virtualization tool? See, there I explained very well that virtualization tool virtualizes the physical machine. Suppose this is the infrastructure which has been located in our data center. So on top of physical machine, we used to install a application or software known as hypervisor. So what this hypervisor does, this hypervisor virtualizes your physical machine. So you can install multiple virtual machine on top of hypervisor. But the thing is that this hypervisor virtualizes with as physical machine. Means suppose on top of this hypervisor you have installed 5 virtual machine. So suppose this hypervisor is having 1000 GB of hard disk and 50 GB of RAM. So you have provisioned 5 virtual machine of 200 GB hard disk each and 10 GB RAM. So you have subdivided all the 5 virtual machine in equal parts. So what is happening here, that this 5 physical machines or this 5 virtual machine will be having the resources in them physically. Means you are physically dividing these resources into the virtual machine. So the same work the Docker also does, but what the Docker does, Docker doesn't virtualizes your resources into the physical machine. Docker virtualizes on top of host operating system. So I am explaining you all the concept of this Docker over here. So see what Docker does. So this infrastructure, suppose it is our data center. So on top of our data center, we got one operating system. Okay, suppose this is our Linux operating system. So on top of this Linux operating system, we will install our Docker. Here we used to install hypervisor on top of data center physical machine. But here we are installing hypervisor. Instead of hypervisor, we are provisioning Docker. We can say it as either as a Docker engine, Docker services, Docker. Names are different, but the concept is same, Docker only. So what we are doing, this is our suppose host operating system. This host operating system is having 1000 GB of hard disk and 50 GB of RAM. So on top of this, I installed Docker engine. So what see in this scenario, what we had seen, that we were able to provision only 5 server out of this 1000 GB hard disk and 50 GB RAM. But see here what Docker will do. I have installed Docker on top of this. Now I can provision multiple server, or in the terms of Docker we say it is a container. So we can provision or we can run multiple container on top of this Docker engine. See, in a hypervisor, what I did, that I have provisioned only 5 servers divided 200 GB hard disk to each of the 5 servers. So what will happen? I can't, means after 5 servers, if I require 6th server, I will not be able to provision the 6th server as I am out of the resource availability. But what the Docker will do, here I have provisioned I ran a container. Suppose I ran CentOS container or any of the operating system container. So Docker will means any container will consume only that much space which is the minimal required space. Means in simple word, I can in the beginning I will explain everything later, but in the beginning I can say in simple word that I divided this 1000 GB hard disk into the 5 virtual machine over here, and but here this 1000 GB, with this 1000 GB hard disk I can run more than 100 containers over here. So you can understand the difference between containers and virtual machine. And there are many pros in comparison to container and virtual machine, which I will explain. But before, first let me explain what is Docker. So what I said, Docker is a virtualization tool. We used to virtualize our means resource availability. But what Docker does, Docker virtualizes on top of operating system. It doesn't reserve any resource and says that no, our resource has been reserved. But other virtualization tool like hypervisor, what they does, they virtualizes on top of physical machine. On top of physical machine, they does the virtualization. So whatever the resources I have assigned to any virtual machine, other virtual machine can't utilize that resource. That resource will be reserved for that particular machine. But this is not the same case in the scenario of Docker. Okay. So in simple word, if anyone asks what is Docker, you can simply say Docker is a OS level virtualization tool. If you will say Docker is a virtualization tool, it will also not be wrong. But if you will say Docker is an OS level virtualization tool, the end user will understand that this person is having a clear concept of Docker. So always I will suggest, if anyone asks what is Docker, in simple words say Docker is an OS level virtualization tool. That's enough. Not say more than this. If the end user expect more than this, then just explain them that what is OS level virtualization. Then try to make them understand that how Docker works, how Docker virtualizes your host level and all. So here in simple terms I can say Docker is an OS level virtualization tool. And here also you can say Docker is a containerization platform as well. Now again, what is a containerization platform and what is the use of this? See, what is the use of containerization platform? I had explained in my previous video where how IT companies work. In that video I had explained. See what happens when a developer has made any code and when they are going to release, when they moved their code from their environment to the testing phase, then what happens? Suppose the tester or operation team says that we are getting a bug in your code is not running fine in our system. So suppose in that scenario the developer code is running in developer's machine, but the same code is not running in the tester machine. This means there is no bug in the code, but the environment dependency is there. Developer has run the code in their, suppose developer has written all the codes, the developer has tested all the codes in their Windows machine. But as every one of us knows that all the services or all the applications runs in the Linux platform. So there might be a dependency of the platform which is causing us the error or bug. So what container gives us? Container, you can simply understand it's a real-time container. In container, what we do? Suppose we are taking a carton box. So we can understand container as a carton box. So what we does in a carton box, we puts all our belongings into the carton box, and when we move from one place to another place, we just carry the carton box, and all the belonging of ours will be moved from one place to another place along with the carton box. So the same concept the containerization also does. What containerization in software company, what happens with the containerization, that all the applications or all the dependencies or all the modules what the developer has developed, they will keep all their modules inside a container. They will make an image of that container and they will just pass that Docker image of the container to the tester or any of the end user who is going to test, so that no dependencies will be there. The OS environment will be same for the tester as well as operation team as well as developer. For everyone, the OS environment will not change. So here containerization comes into the figure. So developer Docker does the two work. Either you can say Docker is a OS level virtualization tool, or Docker is a containerization platform that packages all our application and its all dependencies together in the form of Docker container. Okay, so now you will say that Mr. Amit, you are always saying Docker container. What actually the container is in the term of Docker? So see what actually the container is in the Docker. All this I will explain with the practicals in my next session. So this video is only for the theoretical parts. Here only I will explain the theoretical part, but believe me, you will understand all the concept in my upcoming videos or next part of that, what the container is, how can we create the container, and what is the use of container. Okay, so now move. What is container? So see, if anyone asks in a simple unit that what is a container, so in a simple word you can say container is a running unit of the Docker image. Then if they expect more, then you can explain further. Otherwise, if you want to explain in a single word, a single line, you can say Docker is a running unit of the Docker images. Then here comes what is Docker images. See, what is Docker images? Suppose take any operating system. Suppose you are running Windows operating system or Linux operating system or any operating system. So in terms of Docker, what is, okay, let me explain with you figure. See what happens here. Again I am coming to the same scenario, same picture. See what here happening. In top of the hypervisor, the first process is to provision any of the virtual machine. I can provision. First step is I will assign the resources and all whatever they required, like CPU, hard disk size, RAM, whatever they require I will assign. But the second part is to utilize or to use that virtual machine. The important thing is I have to configure the operating system on top of that. After configuring the operating system, only the user or any end user can use it. So operating system is always the base of any virtual machine or any of the Docker images. So here we are provisioning the operating system. So see here also one difference is there between the Docker and in our virtual machine. So see, in virtual machine on top of hypervisor, suppose I have provisioned 5 virtual machine. So every 5 virtual machine will have its own operating system. Suppose I provisioned Ubuntu, here I provisioned RHEL, here I provisioned Oracle Linux. So all the 3 virtual machine will have its own kernel. On operating system means on kernel. So they will means for if you will take the size of the operating system itself, then believe me, the size of the operating system itself will be more than 2 GB or 4 GB, because they are having all the requirement inside that. They will be having its own kernel, they will be having its own whatever the requirement of an operating system, they will be having all the packages. But this is not in the this is not same in the case of Docker. What Docker does, that Docker will utilize the kernel of the host operating system on top of which Docker is installed. Suppose I have installed Docker on top of ABC machine. So this is ABC is our Linux operating system. So Docker will suppose I have pulled the images of, okay, first let me say what is images. So images will be any operating system, or it can be any application which we can pull and utilize it. So suppose this is our application A, can be our CentOS operating system. So we have compared that in case of virtual machine, this CentOS operating system itself will have more than 2 GB of size. But in case of Docker, what happens, that CentOS operating system will be configured with the minimal requirement. Means if you will compare the size of the CentOS operating system over here, then you will get the maximum size will be 100 or 500 MB. It will be in MB only. So if you will see the difference between here and here. Here the CentOS ISO image is having 2 GB or more than 2 GB of size. The same CentOS is having only 100 or 150 MB of size. And you will ask that how there is a huge difference between the size, and why can't here we can provision with the 150 MB of size. Okay, so the answer is, what Docker does, Docker will, suppose I have pulled images of CentOS from Docker Hub. So what the CentOS image will do, any operating system requires a kernel to come up. So this CentOS, what it will do, from where it will get the kernel, because this 150 MB doesn't have the kernel in it. So from where will it get the kernel? So it will say to the Docker, whenever you are going to run this or bring up these images, this will say to Docker, Mr. Docker, I don't have the kernel to bring up this CentOS image. So please provide me the kernel so that I can come up and I can be up. So what the Docker will do, Docker will provide the host operating system level kernel to the CentOS images. So how much application you install? Suppose you have installed CentOS, you have installed RHEL, you have installed Ubuntu, you have installed Oracle, Linux, multiple operating system you have installed in this. Okay. So all the operating system none of the operating system will have its own kernel. Every operating system will use the kernel of the host operating system on top of which Docker is installed. Okay. So that's why there are many pros of these images. Suppose if I provision the operating virtual machine in case of hypervisor, so to bring up this virtual machine, it will take minimum 20 minutes. If you will suppose you have provisioned a Linux RHEL virtual machine on top of this hypervisor. So if you will power it on, it will take minimum 20 minutes to come up, because all the kernel level, all the booting and all boot level, everything will take time to get configured. But in case of Docker, you know how much time it will take? It will take less than 1 second to come up. It will take time in microsecond. Means it is not going to bring up the kernel, it is not going to configure the boot level and boot everything. So what it will do, when you will run a command or you will give an instruction to the Docker that please bring up the CentOS images, immediately what Docker will do, Docker will give all the configuration details of this kernel to this CentOS images, and it will bring automatically the CentOS image will bring up. So all this thing I will show practically in my next session. For the basic theoretical concept, I am sharing all this. Okay. So you got that what the Docker images is and what is the Docker container is. So see, when I pulled these images, suppose this is CentOS images, this is Ubuntu images, likewise multiple images are there. Okay. So when these images will be in means static state or powered off state, or what you can say as a static state, then you can say it as images. And whenever I will run these images, or I will say when images will be in dynamic state, that we can say it as a container. Means simply container we can correlate with the server. Our running server can be correlated with the container. Okay. So this is, I think this is enough about what the container is and what the Docker is. Everything I will show practical in my upcoming session. So see, I mentioned some point. Any container, any container will must have operating system as the base image. Operating system can be either Ubuntu, CentOS, Oracle, Linux, it can be anything. Just read out this point. I know if you are a beginner, you will not be able to understand this as of now, but believe me, after doing the practicals, you will find this point as a boon, because these all are the real concept. You will not find it anywhere in the books or everywhere. So I have mentioned all the important points over here. You will find it in a very easy way. The second thing is, we can create our own Docker images. We can create, suppose I means inside the Docker images, I can, okay, let me give this also as an example. See, in this case of virtual machine, what I does, this first I provisioned a operating system. On top of operating system, I run an application. Suppose that application can be Java application along with other application as well. So here what will happen, this virtual machine is having suppose application A, but in case of Docker, already I will be having pre-built images in the Docker Hub. Docker Hub is a repository of the Docker where I can pull all the images of Docker. Okay, so suppose this is pre-built images of Docker. Suppose I need Tomcat server. So here I need to install Tomcat server. Before that I need to install Java and all. So these all I prerequisite I have to install. But here in case of Docker, already Tomcat has pushed their official image into the Docker container, and what you have to do, just pull that Tomcat image and just use it. Now the thing comes that, okay, you pulled the Docker images, you pulled the Tomcat images. Okay, now suppose your company requirement is that along with the Tomcat images, you need some extra configuration, like you suppose by default the Tomcat is running on top of Linux RHEL, but your company said no mister, I want to run this Tomcat on top of Ubuntu server. So you can create your own images as per the requirement of the company, but you can't change the already pre-built images. Means you can pull the Tomcat images from the Docker Hub, you can use it for your purpose. But if you are thinking that you can change that Tomcat images, it is not possible. All the images are immutable. You can't make any changes to the images. But yeah, you have the right to make your own images. You can make your own image as per your company requirement. Okay, so that is what here I mentioned, that we can create our own Docker image as per the requirement, but we can't make any changes to the existing Docker image, as the images are always immutable. Okay, now the Docker Hub. What is Docker Hub? Docker Hub is the repository. I think the person who has worked in the Git or GitHub might be aware of what is repository. So see, repository means simply we used to store the Docker images over there. It is means you can just compare the repository as the storage room. We used to store all our contents over there. So Docker has its own repository, which we call it as Docker Hub. So I am also going to show you what is Docker Hub and how it looks like. So you can simply type Docker Hub in Google. You will get Docker Hub. So see, this is the main page of the Docker Hub, where the hub.docker.com, the official website. You can go into the sign in if you have the account, and if you don't have, you can go to the create account. So already I have the account. I am going to log in. So I am going to log into the Docker Hub. So see, this will be the main page or main output of the Docker Hub. So see, if you want to get CentOS images, so see, all the images you can find in the Docker Hub. There are millions of images which is found in the Docker Hub. So see, suppose I want to pull the CentOS images. So you are able to see that if you if you search for the CentOS, you got multiple options. Then with which you have to go for. So see, always try to look into this mark, official images mark. So official images mark means this CentOS images has been uploaded by the CentOS official, means CentOS themselves has uploaded these images, and they used to find update all the versions of the CentOS whenever any new updates or any new things comes in their operating system. So always try to go with these official images. Now I will explain you what these other images are and what is the use of that. So later on I will explain. So see, you suppose you are getting this 10M plus option, means more than 10 million people have used these images or pulled it from the Docker Hub. So here you can see how many versions of CentOS they have pulled, means they have pushed into the Docker Hub, and with the tags you see that how many Docker images are there. Yeah. Now here also one important thing is there. What I said earlier, that what is the CentOS ISO image sizes? It is more than 2 GB. But see, here only 75 MB of the size is there for the CentOS. Means you will get entire CentOS operating system, and that will consume only 75 MB of your space. Now you can correlate with the 2 GB along with 75 MB. How better it is. Then why actually the size is less, I will explain everything in the practical session. But now I am comparing that between the physical virtual machine and this Docker virtual machine. Okay. So the other important thing is you are able to find the latest. Okay. So whenever you will pull any of the images from the Docker Hub, by default Docker is going to look for the latest image. By default, if you will not give any of the specified tags, then Docker will always move for the latest images. Okay. So this is the first thing you have to look into this latest and 75 MB overlay. I will explain everything in the later session of video. Yeah. So we can also push our Docker images to the Docker Hub. Suppose I have created any images as per my company requirement, and I wanted to get it stored over anywhere. So I have the option to push my Docker images to the Docker Hub. Either I can do that, or if suppose as every one of you know that Docker Hub is a public repository. Anyone can pull the images which you will upload in the Docker Hub. Okay. So suppose if you want, no, I don't want my office Docker images to push into the Docker Hub, which is public repository. Then also you have the two options. One is the DTR. And what is DTR? Docker Trusted Registry. DTR. It is actually for the Docker Trusted Registry. So this is actually for the companies. All the companies uses this one. So you can understand now per the overview, you can understand Docker Trusted Registry is the private repository and Docker Hub is the public repository. Okay. And second option again you are having that registry option. You can pull the registry from the Docker Hub. One second, I will show you registry, registry. So one registry option, registry image is there. See, this is the official image loaded by the Docker. So you can pull this registry in your Docker machine, and in the local machine also you can save your Docker images. All these I will explain in the practical session. So simply you can understand the Docker, in the Docker Hub you can push your images and if you want to push in the private image as a private image, then DTR option is there. DTR is Docker Trusted Registry, which is not free open source. You have to pay for the Docker Trusted Registry, and all the companies wish to prefer to go with the DTR as they don't want their images to be public. So that's all about for now. Now whenever we run any container, the first step is Docker will look for this. Yeah, I think you will explain this much better in the practical session, but anyhow, let me just read this line once. See what happens, what is the flow of the Docker that I am explaining over here. Whenever suppose you are pulling for any, you required suppose any Ubuntu images, then there is a command to Docker pull Ubuntu. If you will run this command, what the Docker will do, Docker will search for the Ubuntu images. What Docker will do, first it will search for the images in your local host machine. At Mr. Host machine, do you have this Ubuntu images in you? And suppose if Docker is not able to find the Ubuntu image in the local Docker engine, then it will redirect the power to the Docker hub, and it will ask with the Docker hub that please provide me the latest official version of the Ubuntu images. And it will pull the images from the Ubuntu, and it will give you message that Docker Ubuntu is there in your operating system. You will get the Ubuntu images. Okay. So this you will be able to understand better in the practical session. So I will moving forward. Yeah. Now simply, as if you will talk about the architecture, then in the simple term I can explain you over here, what till now we have discussed, that this is our Docker engine which is installed on top of host operating system. Suppose this is our host operating system, and on top of which I have installed Docker engine. Okay. Now I require the Ubuntu images to be used. Then I will run the command over here, Docker pull Ubuntu. Suppose if Ubuntu images is found in our local host machine or host operating system on top of which Docker engine is installed, then Docker will provide the same images to the Docker image. And if they will not be able to find the same Ubuntu image in the Docker engine, then what they will do, they will pull the Ubuntu images from the Docker hub, and they will just give the container, they will just crypt the Ubuntu images, and they will say the Ubuntu image is ready to use. Now suppose I want to use this Ubuntu image, then Docker run command is there. So I will run this image. See, what is the difference between images and container? When your Ubuntu image in the static state or in the stop state, it can be said as the image. But if I will run this one, and if the images will be in the run state, it will be said as the container. So when I will run this Ubuntu container, immediately it will be supposed as a container. Okay. So now I got my Docker Ubuntu container. This is in the running state. Now I have the flexibility with me. Either I can run the container. If I don't want, I can stop the container. If I don't want forever, I can delete the container. I can pause the container. I can unpause the container. I can stop the container. All the facilities or flexibility we do have for the container. Okay. So this all scenario I will explain you in the practical session. For the theoretical section, just look into this flow. This is the flow of the Docker. Believe me, if you will be able to understand this flow, it will be very easy for you to catch up what the Docker is, how it works. Only then you have to do the practicals with the command, but you will be clear with the concept. Okay. So here I want that you should have a clear concept of what the Docker is, what is the requirement of Docker and all. So this, I think you got the clear picture over here. So now again I am giving you one different definition of the Docker, that what the Docker is. So in simple term, you can say Docker is a tool for build, ship and run. build, ship and run. Now you will say what this build, ship and run. I will explain in very small language, but I will explain in very details in the further upcoming session when you will see the practical, because without practical you will not be able to understand it very clearly. So what here build, ship and run means. I can build images as per my requirement. Suppose my company wants to run a Java application along with the multiple other applications. So I will build images for that Java application along with the other application which I want. I will build that image and I can ship that image to anywhere. Suppose I can release this image to the tester team, to the operational team, to the whatever team they require. I can ship it to anywhere. Ship means I know that moving place from one place to other place. So you can build your images, you can ship your images from your place to any place in the world. Suppose you are sitting in the India and other developer wants the same application to be tested in the United States. Then you can just ship your image within a second to United States, and anyone can run that image. So I think you got the concept of Docker over here. So I think this is enough for today. In the upcoming video, I will come along with what